Describe any two characteristic feature which distinguish between interference and diffraction phenomena. Derive the expression for the intensity at a point of the interference pattern in Young's double-slit experiment. See here, the interference pattern has a number of equal spaced bright and dark bands, while diffraction pattern has a central bright maximum which is twice as width as the other maximum. Next feature, interference is obtained by the superposing two waves originating from two narrow slits. The diffraction pattern is the superposition of the continuous family of waves originating from each point on a single slit. One more we can see here. In interference pattern, the intensity of all bright fringes is the same, while in diffraction pattern, intensity of bright fringes go on decreasing with the increasing order of the maxima. And in interference pattern, the first maximum falls at an angle of lambda by A, where A is the separation between two narrow slits, while in diffraction pattern, at the same angle, first minimum occurs, where A is the width of single slit. Then, displacement produced by source S1, we can write it as Y1 is equal to A cos omega t, and displacement produced by the other source S2, that is Y2 is equal to A cos of omega t plus phi. Then resultant displacement is Y is equal to Y1 plus Y2, that is A into cos of omega t plus cos of omega t plus phi. Then we can write this one as 2 times A cos phi by 2 cos omega t plus phi by 2. Amplitude of resultant wave A is equal to 2A cos of phi by 2. Intensity, that is I, is directly proportional to A square. Then I can write I is equal to K times A square, and we can write it as K 4A square cos square phi by 2. This is the expression for the intensity at a point of the interference pattern in Young's double slit experiment. Then part B, in the diffraction, due to a single slit experiment, the aperture of the slit is 3 mm. In monochromatic light of wavelength 620 nanometer is incident normal on the slit. Calculate the separation between the first order minimum and the third order maxima on one side of the screen. The distance between the slit and the screen is 1.5 meter. So here, the distance of first order minimum from center of central maxima is that is x d1, which is equal to lambda d divided by A, and the distance of third order maxima from center of the distance central maxima is, that is x b3, which is equal to 7d lambda divided by 2 times A. Therefore, the distance between the first order minima and the third order maxima is, that is x b3 minus x T1, then we'll get 7d lambda divided by 2a minus lambda d divided by a. Then we get the value 5d lambda divided by 2a. Then if I'm going to substitute the values, 5 times, that is 620 into 10 to the power of minus 19 into 1.5 divided by 2 into 3 into 10 to the power of minus 3. When we simplify, we get the value, that is 775 into 10 to the power of minus 6 meter, or we can say this one 10 to the power 7.75 into 10 to the power of minus 4 meter. Under what conditions is the phenomenon of total internal reflection of light observed? Obtain the relation between the critical angle of incidence and the refractive index of the medium. The first point, the light travels from denser to rarer media. This is one of the conditions of its phenomenon. Second point, angle of incidence is more than the critical angle for the grazing incidence. That we can write it as mu sin IC is equal to 1 sine of 90 degree. Then mu is equal to 1 divided by sine of IC. Part B, 3 lenses of focal length 10 cm, minus 10 cm, 30 cm are arranged coaxially as in the figure given below. Find the position of the final image formed by the combination. For convex lens of a focal length, we have, that is 1 upon f1 is equal to 1 upon v1 minus 1 upon u1. Then substitute the value 1 upon 10 is equal to 1 upon v1 minus 1 upon minus 30. We get the value, that is v1 is equal to 15 centimeter. Then for object distance for concave lens is that is u2 is equal to 15 minus 5, that is equal to 10 centimeter. We can write this one as 1 upon 10 is equal to 1 upon v1 minus 1 upon minus 30, that is v1 is equal to, again that is 15 centimeter. And object distance for concave lens u2 is equal to, that is 15 minus 5, that is equal to 10 centimeter. That is 1 upon f2 is equal to 1 upon v2 minus 1 upon u2. Get the result, 1 upon minus 10 is equal to 1 upon v2 minus 1 upon 10, which give the result v2 is equal to infinity. Then for third lens, we have 1 upon f3 is equal to 1 upon v3 minus 1 upon u3. Substitute the values, 1 by 30 is equal to 1 upon v3 minus 1 upon infinity. We get the result, v3 is equal to 30 centimeter.